In this video, we will be looking at some different two-column proof examples that involve the use of the theorem we learned on circles and CPCTC. Just as in the proofs we were doing in sections 3.1 and 3.2, we are still going to be trying to prove two triangles congruent. So our first given has QS perpendicular to PR. Our second given, PS congruent to SR. So make sure you put tick marks on the diagram. So let's think, what does this first given mean if QS is perpendicular to PR? Perpendicular, you should automatically be thinking right angles. Which angles are right angles? The angles that are formed by those two segments. So we can conclude from that first given that angle QSP and angle QSR are right angles. To make my life easier, I'm going to put numbers on my angles. So I'll call those two angles, angles 1 and 2. And then my statement would be that angle 1 and angle 2 are right angles. The reason for this has to do with our definition of perpendicular. If two segments are perpendicular, then they form a right angle. The next conclusion we can make from that is that those two right angles are congruent. So statement number 3 would say angle 1 is congruent to angle 2, and this goes back to a reason we learned in chapter 1. If two angles are right angles, then they are congruent. Okay, so now don't forget to copy that second given in your proof. The second given says that segment PS is congruent to segment SR. I've already marked that on my diagram with tick marks. So now we have a pair of congruent angles and two sides of the triangle congruent. We only need one more congruency in order to prove the two triangles are congruent. We don't have any more givens, so we have to take a look at the diagram to determine what is the third corresponding part that we can say is congruent. You should notice that they both share a side. They share side QS. So the third corresponding part would be that segment QS is congruent to segment SQ by the reflexive property. Now we have enough information to prove the two triangles are congruent. And do make sure that you label the triangles correctly. The corresponding angles and sides must line up. So we're going to continue to practice that. So therefore, triangle PQS is congruent to triangle RQS by side angle side, looking at the tick marks. Don't forget to include the step numbers where you have those three congruent corresponding sides and angles. Up until this point, all of this should be reviewed. Now here's the new part where we take it one step further. So looking at this statement, that triangle PQS is congruent to triangle RQS, I notice that angle P and angle R are corresponding angles. So if we think back to what does CPCTC stand for, we know that any of the 6 corresponding parts of those two triangles is always going to be congruent. So P and R, those are corresponding angles. Therefore, the next conclusion we can make after proving two triangles congruent is that angle P is congruent to angle R. Okay, let's take a look at another example of a two-column proof you may see in this chart. We have two givens. Segment AC is congruent to segment BC, so put tick marks on your diagram. And we're also given circle O. Recall that they give us that so that we know which point is the center point. So point O is the center of the circle. So let's start by copying down that first given. AC is congruent to BC. That is given. So now we know we have one pair of congruent sides in the triangles. And then we do need to copy down that second given, circle O. Notice that both of the triangles share segment CO. So the next conclusion we can make is that CO is congruent to OC by the reflexive property. There was that new theorem that we learned about radii, that all radii are congruent. So the next conclusion we can make is that segment AO is congruent to segment BO because all radii of a circle are congruent. So this is an application of that new theorem we learned about circles. And then finally, now we can prove the two triangles congruent. So triangle AOC is congruent to triangle BOC by side, 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 and don't forget to include those step numbers. So you have a side in step 1, a side in step 3, and a side in step 4. Now we are going to take it one step further because we want to prove the two angles at the top. Angle AOC is congruent to angle BOC. Those are corresponding angles in the triangle. And so we can make that conclusion right after proving the triangle's congruent by CPCTC. So now what I'd like you to do is please pause the video, try the last two proof examples on your own, and then once you have finished them, press play again to check your answers. Okay, in example 3, we have 3 givens. So I would label segment GC congruent to GF, angle C congruent to angle F, with tick marks on your diagram. So far we have 2 congruent sides and a pair of congruent angles in the outer 2 triangles. So we just need one more thing to get the triangles congruent, and it has to do with that third given. Recall that the word trisect means it divides it into 3 congruent parts, but we really only care about CD being congruent to EF because those are the 2 sides in the triangles. So I would say then that segment CD is congruent to segment EF because if 2 points trisect a segment, then they divide it into 3 congruent segments. But again, like I said, you really only need the 2 that are in the triangles. So then you would have enough information to prove the triangle's congruent by SAS. And then GD is congruent to GE by CPCTC. Notice that GD and GE are corresponding sides in the triangles. So that step comes right after proving the 2 triangles congruent. And the final example, example 4, we have 2 givens, so labels angle 1 and 2 congruent using tick marks on the diagram. So that's a pair of angles in the triangle, but we need 2 more things. So if we copy down the second given, R is the midpoint of PS. Remember the word midpoint means it divides it into 2 congruent segments. So if we look at segment PS, that means that segment SR would be congruent to RP. If a point is the midpoint of a segment, then it divides it into 2 congruent segments. So now we have an angle and a side. We need one more thing. So looking at the diagram, angles 3 and 4, those are vertical angles. So we can say that they are congruent by our theorem from chapter 2. Angle 3 is congruent to angle 4 because vertical angles are congruent. So therefore, we have enough information to prove the triangle's congruent by angle, side, angle. And notice that segment PQ and TS, those are corresponding sides in the triangles, so we can make our final conclusion by CPCTC. Now you should have a better idea of how to use CPCTC and the circle theorem.